Hello guys and welcome back. Today we're going to talk about DC motors. We're going to talk about applications of DC motors, describe the electrical characteristics of DC motors, describe the field structure of a DC motor, change the directional rotation of a DC motor, identify the series and shunt fields and amateur windings with an ohm meter, connect the motor leads to form a series, a shunt, or a Tampel motor, describe the differences between a differential and a cumulative compound motor. So let's get started. Applications. DC motors are used in applications where variable speed and strong torque are required. They are used for cranes and hoists when those must be started slowly and accelerated quickly. DC motors are also used in printing presses, steel mills, pipe forming mills, and many other industrial applications where speed control is important. Which brings us to speed control. The speed of a DC motor can be controlled by applying variable voltage to the armature or field. When full voltage is applied to the field and reduced voltage is applied to the armature, the motor operates below normal speed. When full voltage is applied to the armature and reduced voltage is applied to the field, the motor operates above normal speed. Motor construction. The armature. The armature is the rotating part of the motor. It is constructed from an iron cylinder that has slots cut into it. Wires wound through the slots to form the windings. The ends of the windings are connected to the commutator, which consists of insulated copper bars and is mounted on the same shaft as the windings. The windings and commutators together form the armature. Carbon brushes, which press against the commutator's segment, supply power to the armature from the DC power line. The commutator is a mechanical switch which forces current to flow through the armature windings in the same direction. This enables the polarity of the magnetic field produced in the armature to remain constant as it turns. Armature resistance is kept low, generally less than 1 ohm. This is because the speed regulation of the motor is proportional to the armature resistance. The lower the armature resistance, the better the speed regulation will be. Where the brush leads extends out to the motor at the terminal box, they are labeled A1 and A2. field windings. There are two types of field windings used in a DC motor, and they are series and shunt. The series field is made with a few turns of large wire. It has a low resistance and is designed to be connected in series with the armature. The terminal markings are S1 and S2. They identify the series field windings. The shunt field winding is made with many turns of small wire. It has a high resistance, and it is designed to be connected in parallel with the armature. Since the shunt field is connected in parallel with the armature, line voltage is connected across it. The current through the shunt field is, therefore, limited by its resistance. The terminal markings for the shunt field are F1 and F2. Identifying the windings. Windings of a DC motor can be identified with an ohm meter. The shunt field winding can be identified by the fact that it has high resistance as compared to the other two windings. The series field and armature windings have a very low resistance. They can be identified, however, by turning the motor shaft. When the ohm meter is connected to the series field and the motor shaft is turned, the ohm meter reading will not be affected. When the ohm meter is connected to the armature winding and the motor shaft is turned, the reading will become erratic as the brushes make and break contact with different commutator segments. Types of DC motors. There are three basic types of DC motors: the series, the shunt, and the compound. The type of motor used is determined by the requirements of the load. The series motor, for example, can produce very high starting torque, but its speed regulation is poor. The only thing that limits the speed of a series motor is the amount of load connected to it. A very common application of a series motor is the starter motor used on automobiles. Shunt and compound motors are used in applications where speed control is essential. Notice that the series motor contains only the series field connected in series with the armature. The shunt motor contains only the shunt field connected parallel to the armature. A rheostat is shown connected in series with the shunt field to produce above normal speed. Direction of rotation. Direction of rotation of the armature is determined by the relationship of the polarity of the magnetic field of the armature to the polarity of the magnetic field of the pole pieces. To reverse the direction of rotation of the armature, the magnetic polarity of the armature and the field must be changed in relationship to each other. The armature leads have been changed. When the direction of rotation of a series or shunt motor is to be changed, either the field or the armature leads can be reversed. Many small DC shunt motors are reversed by reversing the connection of the shunt field leads. This is done because the current flow through the shunt fields is much lower than the current flow through the armature. This allows a small switch instead of a large solenoid switch to be used as a reversing switch. Double pole double throw switch used to reverse the direction of rotation can be used when a compound motor is to be reversed. Only the armature leads are changed. If the motor is reversed by changing the shunt field leads, the motor will be changed from a cumulative compound motor to a differential compound motor. If this happens, the motor speed will drop sharply when load is added to the motor. Standard connections. When DC motors are wound, terminal leads are marked in a standard manner. This allows the directional rotation to be determined when the motor windings are connected. The direction of rotation is determined by facing the commutator end of the DC motor, which is generally located on the rear of the motor, but not always. And that will be it for today, guys. Thank you so much for watching. And again, please like, share, and subscribe. See you tomorrow.